So guys, you can see the app is connected. I press this button over here. See, it will disconnect the SC05. See, and that state LED over here turned off. Now again, I connect it. Now if the connection is successful, state LED will turn on. See, connecting to SC05, it's connected and the state LED is off, indicating that the connection is successful. Now I send a F. F will cause the vehicle to move forward. Now I send F. See, it's going forward. See, I press it again. You can adjust this delay. I had shown you in the code. I will also give the code in the description. You can adjust the delay as you want. It's 100 millisecond right now. See, now I send B. It will move backward. See, it's going back. Now I send L. It will go left. See, it's going left. Now I send R. It will go right. See, it's going right. That's simple as that. And when I send nothing, it will stay like this. There is no noise, nothing. That's the beauty of Bluetooth. So guys, hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can use a HC05 Bluetooth module to make a remote control car using L29810 motor driver module. That's a H-bridge module. Basically, L29810 is an H-bridge IC. We are going to use its module, easily available in the market. And the microcontroller we are going to use is the PIC16F877A, and we will run this car using our mobile phone. Our mobile will act as a remote. We will use the Bluetooth of our mobile phone. So guys, let's get started. So guys, we are going to use HC05 in the default setting mode. So by default, the name of HC05 on your Bluetooth will be appear as HC05. This will be the name, and the baud rate will be 9600 by default. Password is 1234. Default mode means we are in the data mode. There are two modes. One is a command and one is the data mode. In the command mode, you can change the baud rate, name, password, etc. But we are going to go with the default setting. Default setting are those settings when you buy the module. By default, they come in the default setting. These are basically the factory setting. So that's normally the case. So these will be our specs. And finally, the auto pairing to last on one device is also on. This means that whenever you will turn on the HC05 module, it will auto pair with the device it was last connected to. So these are the default settings we are going to use here. I will also make a video on how you can change these settings. That's not an issue. That's an easy task. I will also make a video on that as well. But right now we are going to use the default settings. So guys, let me give you a little insight to L29810 module that we are going to use here. This is the module we are going to use here to drive our motor of our 4WD car chassis. So as you can see that it has three terminals here. One is the 12 volt, other is a ground, other is a 5 volt. Now this 12 volt is basically the motor power, the motor that you will connect to these output ports, these two terminals. And the right one is for the L29810 IC, that's the 5 volt. And then there is output 1, then there is output 2. And this is for one gate. It has two gates. This IC has two gates. Left one is the first gate, this is the first gate, and this is the second gate, output 3 and 4. Now guys, here you have these jumpers. You can see the top pin is the 5 volt on both sides. So you place a jumper here because the next pin is the enable pin. These are the enable pin. If you want to enable a gate like IN1 and IN2 belongs to first gate, if you want to enable this gate, then instead of giving 5 volt from separate source and jumping in a jumper wire, you directly just place a jumper here. That's why this 5 volt pin is there. Similarly for this gate as well, IN3 and 4 are for this gate. IN3 will enable, IN3 and 4 will enable this gate, IN1 and 2 will enable the left gate like this. Then guys, suppose this is our motor A. Then when you will place a jumper A will enable this gate. Now you can use this motor using IN1 and 2 pin. See, if you give 1 to the IN1 pin, it will move in one direction. If you give 1 to the IN2 pin, it will move in the opposite direction. But only one at a time. Either IN1 will be high or IN2 will be high. Both high means stop. Both 0 means stop. Now for the second gate, enable B, you give the 5 volt to the enable B pin. This is the enable B pin. You just place a jumper here for the enable B and jumper here for the enable A. Both the gates will be enabled. Now guys, again, if you give 1 to the IN4 pin, motor B will move in one direction. If you give IN3 pin 1, then that motor B will move in the opposite direction. So IN3 and 4 are for the motor B, IN1 and 2 are for the motor A. Now guys, this here is a 7805 voltage regulator. You can see that this IC, and this jumper, if you place the jumper here, then you don't have to give separate 5 volt to the L29810 IC for the IC. You just place a jumper here, it will auto convert the 12 volt to 5 volt, just like a normal 705, and this is a great feature. Usually these TT motors work good at 8 to 10 volt, and maximum I suggest is 12 volt. Then you can use this. If you are using some other type of motor that require like 24 volt, then avoid using this jumper. Then you have to give 5 volt through this terminal. But in our case, we are going to use a TT motor, a 4WD chassis. So this is fine. We are going to just use a jumper here. So 5 volt will be like 12 volt will be converted to 5 volt. That's all. So this is just like a normal 7805 regulator, as you can see as well. It is mentioned on the body. Now guys, this is our setup here. This is the 4WD chassis I am going to use. Don't get confused by this wiring. These are long wires. I just rolled them up. There is no enough wiring. Now you can see that I had labeled the 12 volt and the ground, and then you simply use a battery or a DC power source, whatever, but in a vehicle a battery is preferred. You use a 7.4 volt battery, that's enough to drive this circuit. So two 1865 cells, these two cells are enough in series. Just charge them well, they must be fully charged. So you connect the positive of your battery to the 12 volt and negative of your battery to the ground. Then guys, this 5 volt, you use a jumper here. So this 12 volt will be converted to 5 volt using the 7805 on board regulator. That's a good thing about this module. Now guys, here you can see that your motor has two terminals. Here two terminals, then again two terminals here, two terminals here. Total we have 4 TT motors. Then guys, we have output 1 and output 2. That is the 1, 2 is the 2. And then we have output 3 and output 4 like this on the L298N. Now you common these two in the cross like this, and you send it to the output 1. Similarly, do it for the lower side. You send it to the output 3, and do the same for the top side. You cross short them in the cross and then send it to the output 2. Similarly, do it for the bottom. You common them in the cross like this for both the motors, and then you send it to the output 4. Now you have to make sure that whenever you connect this to the 5 volt supply, both of these motors on the top should move in one direction, and at the bottom they should also move in same direction. So when we do the programming, we will send a pulse. So one pulse will enable this gate. So these motor will move in same direction. They will act as a single unit. So these two will act as a single unit. You have to maintain their direction. If this is not working, just shuffle the pins. It might be the state, but in usual case, it is always in the cross because they are opposite direction. See, this motor is that facing and that facing. So these are always in the cross. Now guys, here we go. Now what you have to do is that you have to also send this ground over here to the PIC as well. This ground will also go to your PIC as well, because we will send these are the 4 input pins, IN 1, 2, 3, 4 here. These logics will come from the PIC, but you have to make sure that this ground is common with the PIC, else your circuit will not work. Okay, now the next thing is, let's get to the PIC and bring in our SC05 as well. This is our L298 and this is our PIC16F877A DIP version having 40 pins. And guys, let's first show you how to do it. Again, you do the same here. You use the enable jumper like this, jumper on both enable pins. Then guys, here enable gate A is enable, left gate is enable, output 1, 2, right gate is enable by using this jumper at enable B. Now guys, you connect your input pins. IN1 I will connect to the B5. You can use any digital input output pin for this. I'm going to use a pin number B5 of port B, B4 for the IN2, B3 for the IN3 and B2 for the IN4. That's all. So guys, remember that this ground over here is also connected to the ground of the PIC. So you have to make sure that it's common with the ground of the PIC. Then guys, this is our SC05 module. As you can see, it has 6 pins, 1, 2, 3, 4, 5, 6. Let me label them for you. The bottom one is the enable, then you have VCC, then ground, then TX, then RX, then state. These are the 6 pins. Let me show you how to connect it with the PIC. Now guys, for the state pin, you will need a LED. An LED has 2 pins, one longer, one shorter. And then you will use a 220 ohm resistor. It can be 100 to 500 ohm. Remember, do not exceed like 500 ohm because LED will get much dimmer. Now you connect the state pin to the one end of the 220 ohm resistor like this. Then from the other end of this 220 ohm resistor, connect it to the LED. Now for the ground of this LED, send it to the common ground of the PIC like this. Guys, remember that this state pin will only give a high signal. That means that this LED will turn on if your Bluetooth module is successfully connected. When you are trying to detect a device and you have detected your SC05 and then you connect it, if the connection is successful, then this LED will turn on, else it will remain off. So this shows that either the connection of the SC12 module, SC05 module with your Android device, mobile phone, or whatever the device you are using is successful or not. If it's successful, it's on, else it's off. Now we have RX and TX pins here. They are the UART port, so we will need the UART port of the PIC. So you connect the RX pin to the pin number C6 of the PIC, that is a TX pin of the PIC, pin number 25. Then for the TX pin connected to the RX pin of the PIC, that is pin number 26 of the PIC, like this. Then ground will go to the common ground, VCC will go to the VCC, and leave the enable floating because we are using the data mode. In case of data mode, either you make the enable go low or you leave it as it is. That's all. Now guys, remember that this ground I had forgot to connect it here. You have to connect this ground to the common ground of the PIC. This ground will go here like this. Okay. Now guys, the next thing is our connections are completed here. Now we can move on to the programming. Now what I'm going to do here is that I will send F. F means move forward. The whole vehicle will move forward. When I will set a character of R or B, B it means backward. It will move reverse. When I will send left, it will move left. When I will send R, it will move right. That's all. So let's get to our hardware before we move on to the programming. So guys, this is the hardware here. This is our PIC16F877A microcontroller. This is a battery. This is the L298N module. These are the 4 wires coming to the port B as shown in the presentation. Then guys, this is the state LED here. This LED only will be the state LED. This is our HC05 module there right next to the PIC. So this is our total setup here. And let's get to the MikroC for PIC and let's do some programming. So let me zoom in for you so you can see better. So guys, the MikroC for PIC I'm going to use is version 7.2.0. I click on File, New Project. This window pops up, New Project Wizard. Click on Next, write the name of the project. I write HC05 car tutorial by learning microcontrollers, like this. Now guys, PIC16F877A is the one I'm going to use. Select the path where you want to generate the hex file and C file. Now write the name of the crystal you are going to use. This is a crystal connected to the pin number 13 and 14 of the PIC16F877A. Remember that PIC16F877A don't have internal oscillator, so you have to write the value whichever the external oscillator you had connected here. If it's 16 Hz, the megahertz, then write that 16 here. I have a 20 megahertz over there, so I'm going to use the 20. Click on Next and finish. Now guys, this window pops up. Before you do anything else, first of all, save your work. Press Ctrl S. Now the work is saved. Now the next thing is we are going to use the HC05 module. For that we need to initialize a UART port. So you go to the right in the libraries, expand the micro library, the system libraries. Here you write the UART in the search bar. Check mark the UART library. Double click on the UART1 INIT. This will lead you to this window. Here in the example, here you have this command UART1 INIT. You copy it, paste it here. Now inside it the baud rate is 9600. That's good because our default baud rate is also 9600 as shown in the presentation. So that's fine. Give some initialization to that. This is not necessary, but I suggest you always give it in the one-time loop. Now guys, the next thing is we have 4 pins B5, B4, B3, B2 for the L298N module for driving the motor. So we need to initialize those pins. So I use TRISB equals to 0B 1 2 3 4 5 6 7 8. So this is a binary way of giving out states like low high states to a port. So here this is B0, B1, B2, B3, B4, B5, B6 and B7. Total 8 digits and each digit represents 1 pin. This is B0 and moving to the left is the B7 pin. So we have B0, B1, B2. This is our IN4, IN3, IN2 and IN1 pins. So let's this is like digit pin mode input output command in case of Arduino IDE. So in case of MikroC we use a trace register. 0 means output, 1 means input. So all the L298N pins, because they are signal pins, they must be the output. So 0 means its outputs. Now the initial state, initially all the pins must be off. Like we should not be sending any value to the motor like this. So initially they all are off. Now give some initialization delay as well here as well. So guys, now we have our L298 motor driver pins initialized. and the SC05 pins initialized. Now we can move on to the forever loop. Write down while 1, forever loop starts here, ends here, and inside it write down, first of all we will need to read the value coming from the SC05 module. So for that purpose, go to the right. In the UART1 library, you have this UART1 read command. Double click on it. This command over here. Copy this till here. Now paste it in the forever loop. See that what it's gonna do is that if UART1 data ready, if there is some data available in the RX buffer, only then it will enter this loop, and this will store the char coming from the SC05. We are going to send chars from the SC05. So we need to initialize the char variable which will store the char coming from the SC05. We write char, I write SC5, that's all. So copy this, replace this with your char. Now guys, this variable will store the digit coming from the sensor. Now if SC5, the value coming from the sensor, is double equal to F, if it's forward, then what's going to happen? Then the motor will move forward. As told earlier, we have, I label them as well as shown in the presentation. We have pin number B5 equal to I and 1, B4 equal to I and 2, B3 equal to I and 3, and B2 equal to I and 4. So guys, IN 1, 2, 3 and 4 started from B5 to B2. So B5 is the IN 1 pin, then IN 3 is B3. So this means that this is our second gate and this is our first gate. So B5, B4 are for the IN 1 and IN 2. IN 1 and IN 3 will cause a motor to move forward. Now you have to be careful here. If you had followed my wiring, then well and good. If you have done opposite wiring, then that's not an issue. You can simply cater for it in the programming. You simply go B5 and B2. This will be the forward direction. But in my case, it will be B5 and B3 because I have done the coding in such a way, I have done the wiring in such a way that when I give 1 to the B5, IN1 pin and IN3 pin, then they both move in the same direction. If you have a little bit of problem, then you may try IN2 and IN3. That will be the forward. So you have to one time like test it. So I do is that IN1 and IN3 must be on. So I write this command here, that is the initial state. So this is B0. So IN1 is B5 and IN3 is B3. So 0, B0, B1, B2, this is B3, this is on now, this is B4 and this is B5. So B0, B1, B2, B3, B4, B5, B6 and B7. Now see that for the forward, B5 and B3 are 1. IN1 and IN3 are 1 as per my wiring. If you follow this, then this will turn on, this will cause the motor to move in forward direction. For how long? I make it like whenever F is given for 100 milliseconds, it should keep on moving in the forward direction. Okay, or I make it 200, that will be better. You can adjust the delay depending upon what step you want to set. Like if you keep it 50, it will only move for a 50 milliseconds. That will be a stop tick. So you have to continuously send the digits. If your application allows you to send a bigger pulse, then simply send it for like 100, make it 1000. That whenever F is received, it will move forward for 1 second. Now guys, else if F is not received, make it else if, write down else. B is received from the SC5 module, then it will move in the opposite direction. Now for the opposite direction, these two will be IN2 and IN4 will go high. So IN2 is B4 and IN4 is B2, B4 and B2, B0, B1, B2. Now this will be high, this have to go low. Now this is the benefit of using this. B0, B1, B2, B3 and B4, while the rest of the all will go low, go back to the initial state. Now this is the benefit of using this, sending the bits in binary to the port. Else you have to do is that you have to write 4 commands here. You have to write 4 commands, like you have to turn off this, else it will be keep on moving forward. You have to turn this off and you have to turn this on. You have to write 2 commands, like you have to write b.f2 equal to 1, b.f4 equal to 1 and B dot this one 0, this 0, rest will be 0, 2 will be 1, 2 will be 0. So in this way you only have to write one command. So this is a pattern way of doing it. Now again write else if. Now we have to write for the left. I write L. Now for the left, what is going to happen is that IN1 and IN3 are for the forward. Now IN1, that this will move in one direction, and then IN4. IN1 and IN4 will move in the opposite direction, causing the vehicle to either move to the left or right. I am not sure it is going to go left or right, but it is going to, we can adjust it later, doesn't matter. So for the left, IN1 and IN4, that is B5 and B2. So this is B0, B1, B2 is already high, B3, B4, make it 0, and this is B5. B0, oh, I think we made a mistake here. Okay, for the back we had IN2 and IN4. IN2 is B4 and B2. B0, B1, B0, B1, B0, B1 and B2 is high, B3, B4, that's fine. For the left we should have IN1, B5 and B2. B0, B1, B2, B3, B4 and B5. See, for the left we have B0, B1, B2, B3, B4 and B5. Okay, we have B5 and B2 high, so this will go left. Now we make it for the right. Similarly, do it for the right. Write OR. Now if the OR is received, then the other two, that is B4 and B3 will go high, IN2 and IN3. So B3 and B4 should be high. B0, B1, B2, B3 and B4 are high now. Rest all are off like this. Now write else. In the else, just if nothing is sent, now there is an important thing to be done here. One thing is this, that the motor should remain in the initial state, that is all the motor driver pulses should be 0, and this HC5 must have any character other than the one being used in the programming. So HC5 equal to, just make it something which is not being used here, Z. See, and also make this like this in the one time loop as well. So when the code starts, motor should not work. If you don't do this, then there is a possibility that the F you had given is still F. Motor will, once you send an F, it will keep on repeating the F because you had not changed the HC5 value. If you send B, it will keep on moving in the backward direction until you do not send something else. So you have to be careful with this. You can give any character other than the one being used here. So for F is forward, B is backward, L is left, R is right. So that's all. We build this code and see what happens. So it's built successfully. Let's burn it. Okay, open the PIC16 programmer, click on file, import hex file. This is the file, click on write. Okay, the new code is being written. Let's get to the hardware. Okay, this is the hardware. Okay, I will power this up to check do something happens or not. See, no value is being given. So we have to now connect our app now. Okay, you go to the Play Store, and in the Play Store there are many terminals available. Just write here. What should I write here? HC05 Bluetooth terminal. Let me connect the Wi-Fi. So guys, this is the Android phone I'm going to use here. Let me first connect to the Wi-Fi. Okay, it's connected. Go to the Play Store, and on the Play Store you have many HC05 apps. Just write down here HC05 Bluetooth terminal. Just write down here. You will get many terminals. So as you can see the top one is the serial Bluetooth terminal. Just select this one because it's the first one. You can use any, they all do the same. Install it. You can even download the APKs, they are also fine. Okay, let it install. Okay, it's installing. Okay, enable, open. Okay, it's open. Now right now go to the left. Here you have devices. Click on devices. Okay, the Bluetooth is disabled. First enable the Bluetooth. Go down, turn on the Bluetooth. Bluetooth is on. Now refresh. Okay, see HC05. This is what I am talking about. By default, the name is HC05. Now you can, so now you can see better. See that this is HC05. I touch on it. See, now you can see this symbol. It's connected. It says it's connected, and you can see the LED is on now. See this LED. This is the state LED. I turn off. I press this again. See, LED turns off. Now I connect it. LED turns on if it's connected successfully. See, now it's connected successfully. Now I turn it off. See the difference. This is off and the HC05 is blinking very fast. See, now I press it. The state LED will turn on if the connection is successful. Connecting to HC05. See, now it's connected successfully and the LED is on now. Now guys, our circuits are on. We can send commands. We check, okay, it's powered up. Now we send a command F. I write F. This is F. I send it. See, it moved forward for 100 millisecond only. I send again. I keep sending it. See, it keeps on moving forward. Now I send B. Okay, remove the F and write B. Now I send B. See, it is moving backward in the opposite direction. See, now it's B. Now I send L. See, now it's moving in the left direction. It's left or right, you can adjust it. See, I press it faster. You can increase this ticking, like it's 100 milliseconds. You can increase the delay. You can play with the code. I will give you the code in the description of the video. See that? It's fine. Now I write R. Now it's R. See, now it's going right. See, it's simple as that. See, now I again send forward F. See, it's going forward. See, again I go left. Now right. See, now I go back. This is simple as that, guys. So if you have any questions, you can ask in the comment. I hope you learned something from this video. Now guys, we'll see you in the next video and have a nice day. Goodbye.